We are the team three of mechanics and environment, and we are present you our Pia project. I'm Sofia Gomez.
Sophia Ariel.
I'm Jimena.
I'm Melanie.
I'm Denise.
For our Pia project, we made experiments with four types of shoes, and we tested in different surface, one in dry surface and the other in a wet surface. And we test the friction when it slides, and we calculate the different concepts like the coefficient, or if it has more static or kinetic movement.
Theoretical framework. Friction is the force that resists the sliding of an object over another, and the coefficient of friction is considered as the frictional force that resists the sliding and resists the motion produced by the surfaces when they are in contact. The coefficient of friction is divided into kinetic and into static coefficients of friction, and they have different values. The definition of the main key concepts of this PIA project is frictions, which is the force that resists sliding, the coefficient of friction, which is a measure of the amount of friction um, that exists between the surfaces, and the static coefficient of friction, which is a measure of the amount of friction existing between two surfaces when they are at rest, and the kinetic coefficient of friction, which is the measure of friction that exists when the objects are moving. Also, the natural force, it is constant interaction between the body and its surface when it is in contact. The independent variable of this project is the type of shoe, the surface conditions, the inclination, and the inclination of the angle. The dependent variable is the coefficient of friction and the angle measured, and where the angle slips, also the force of friction. And the control variable is the weight of the shoe, the material, the surface, and the humidity, if it's wet or if the surface is dry, which we both tested on the shoes we used. Friction is a key factor when we are considering footwear designs. Some shoes are designed to be slip proof, so they have more grasp um, on wet surfaces. But on the other hand, some shoes slide more easily when wet. So it really depends on the material and what the shoe is made for. For example, hiking boots or Crocs will not have the same coefficient of friction and will not act the same when a surface is dry or when a surface is wet, as well as, for example, soccer shoes. They will act very differently because they have little steps on the bottom to prevent the sliding on the grass when the players are playing football. Um, some materials, as already mentioned, they prevent slipping, but some others focus mainly on comfort and are designed for daily use instead of um, when raining. And um, displayed will be the resource we use to find out the coefficient of friction. The formula we used is coefficient of friction equals the tangent times the average critical angle.
Here is the first experiment with hiking shoes. And in the experiment with a dry surface without water, it splits at 40 grades and with water at 45 grades. grades. And for the second one is with a high heel boots and with water it slides at 34 grades and with water at 29 grades. For the third one are normal boots and with the surface without water is slides at 32 grades and with water at 24 grades. Lastly, for the fourth experiment, we in the dry surface we have a converse that slides 32 grades and in a wet surface 34.
For hiking shoes, the coefficient of friction was 0.83. For high heel boots, it was 0.87. For boots, 0.62. And for Converse, it was the same, 0.62 degrees. Then for the coefficient of friction, wet, for the hiking shoes was 1 degree, for the high heel boots was 0.80 degrees, for the boots was 0.44 degrees, and for the Converse it was 0.67 degrees. The reported coefficient of friction, dry, in an angle of 15 to 18 degrees, is between 0.26 to 0.32. In an angle of 13 to 18 degrees, it is in 0.23 to 0.32. In an angle of 18 degrees to 21 degrees, 0.32 to 0.38. In an angle of 20 degrees to 21 degrees, 0.36 to 0.38. And in the report coefficient of friction, wet, in an angle of 13 to 18 degrees is in 0.23 to 0.32, and an angle of 20 to 21 is 0.36 to 0.38. In an angle of 13 to 15 degrees is 0.23 to 0.26. In an angle of 18 to 21 degrees, 0.32 to 0.38.
Okay,
Then
in the results, as you can see in the most of the cases, the different types of shoes in the wet surface, there is a greater coefficient of friction, except in the case of the boats.
well, we used different shoes for different shoes, as my teammate said, and in a dry and a wet surface. In our case, with the wet surface in the shoes, we had less grip, so it needed a small angle except for the Converse. And for example, we use, well, the materials for the sole of these shoes were rubber and plastic. Rubber is a more like it has more grip, so it had less grip, so it also like slides easier than the plastic. That plastic Converse were plastic, so it slides easier. And also, so another thing that affects on the angles of
the plane is the weight of the shoes. That, for example, for the boots, we had less degrees, angle degrees, so it also slides easier.
Conclusion and reflection. With the information we obtained, we can correlate it with the second Newton law that establishes when a body has a force not equal to zero, that means it moves in different directions. The acceleration is directly proportional to the force and inversely proportional to the mass. Also, we can correlate it with the types of friction force that are two, the static and dynamic. But in this case, it's the static because it's resist to the initiation of the motion, and also with the coefficients of friction that demonstrates in which type of surface is sliding. And with this, we can conclude that depending on the conditions of the surface, the coefficients of friction may vary. And for example, in the case of the wet coefficient may be more than the dry coefficient, but the material used is the same. And something we find interesting during our experiment is how wet can influence the slide of an object.
And that will be it. Thank you.